for the participants to come on?
We can start now, Agam? We can start now? Okay.
Yeah,
We will start now, Dr. Shahnawaz.
yeah. There is our Dean Faculty. Hello, Prof. Bambang. Good afternoon. Okay. Okay. Get part.
Okay. Okay. Is it go?
Okay.
Okay. Okay. Bismillahirrahmanirrahim. Okay. Ladies and gentlemen, attention please. Our opening ceremony is about to begin. Ladies and gentlemen, good afternoon. Welcome to Untitled Lecture Series, Geoinformatics for Agriculture, Opportunities and Challenges, organized by Agroecotechnology Study Program, Faculty of Animal and Agricultural Sciences, Universitas Diponegoro, Semarang. Ladies and gentlemen, it is a great honor for me, Irfan Yusuf, as Master of Ceremony, to be here and welcome every one of you in. Ladies and gentlemen, over the next few hours, this meeting will provide you plenty of opportunities to discuss, share knowledge and insight. Ladies and gentlemen, before we proceed to the main program, we would like to express our sincere gratitude to Honorable Rector of Universitas Diponegoro, Professor Dr. Yos Johan Utama, SH.M.Hum, Honorable Dean Faculty of Animal and Agricultural Sciences, Universitas Diponegoro, Profesor Dr. Insinyur Bambang Walio Hadi Eko Prasetyono, MSM Ager IPU, Honorable Head of Agriculture Department, Dr. Heni Rizkyati, SPT MSI, Honorable invited speaker, students, and participants. Ladies and gentlemen, before we proceed to the main agenda, we are now going to listen to our national anthem, Indonesia Raya. Ladies and gentlemen, we are now going to listen to the opening speech delivered by the Dean Faculty of Animal and Agricultural Sciences, Universitas Diponegoro, Profesor Dr. Insinyur Bambang Walio Hadi Eko Prasetyono, MSM Ager IPU,
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, students and all participants who is joining us online by Zoom meeting. We are welcoming you to the invited lecture series organized by Agroecotechnology Study Program, Faculty of Animal and Agriculture Sciences, Universitas Diponegoro. And thanks you very much for your participation in this event. First, thank you to the Honorable Rector of Universitas Diponegoro Semarang, Professor Dr. Yoswan Utama, SH MHum, who always support us. Second, may I thank the speaker or the invited lecturers, Dr. Shahnawaz, International Project Coordinator, Department of Geoinformatics, GIS, University of Salzburg, for taking part in invited lecture series. It is my great pleasure to welcome you to the Universitas Diponegoro, Faculty of Animal and Agriculture Sciences. Universitas Diponegoro is the reputable faculty in Indonesia and in the world. Faculty of Animal and Agriculture Sciences has 7 study programs, starting from Bachelor of Animal Science, Bachelor of Agroecotechnology, Bachelor of Food Technology, Bachelor of Agribusiness, Master of Agribusiness, Master of Animal Science, and Doctor of Animal Science. The 3 study programs at Faculty of Animal and Agriculture Sciences have also received international accreditation. Based on the QS World University ranking, our faculty managed to rank 400 plus in the world in the field of agriculture. Even the QS Graduate Employability Ranking put Universitas Diponegoro in first place. Every year, we are holding our annual event, which is an invited or visiting lecture. As we come together today with the topic of geoinformatics for agriculture, opportunities and challenges. Through this invited lecture program, we hope the students may enlarge their knowledge of geoinformatics for agriculture. We are truly grateful for this. So by coming here, you are helping us to build and develop the knowledge that is related to the geoinformatics for agriculture that will be faced by our students. Last but not least, my deepest gratitude goes to the all committees who have directly and indirectly supported the success of this invited lecture program. Although we try our finest to be professional, on behalf of Universitas Diponegoro, please accept our sincere apologies should there be inconveniences that occurs before, during, or after the event. With these words, I declare the invited lecture series opens. may God bless us all with good health to make this event a successful and enjoyable one. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Insinyur Bambang Waliyo Hadi Eko Prasetyono, MSM AGR IPU, for the delivered speech. Ladies and gentlemen, before we move on to the main agenda, let us take some pictures to immortalize this very moment. For all participants, we may allow you to turn on your camera to commemorate this moment. Ready? 1, 2, 3. And on to the next slide. Ready? 1, 2, 3. And on to the last slide. Ready? 1, 2, 3. Thank you, everyone, for your sincerity.
Okay, you're welcome. Thank you, Dr. Shahnawaz.
Thank you very much.
Okay,
Terima kasih Pak Dekan.
yeah, you're welcome.
Ladies and gentlemen, now we come to our main program. We will be directed by our moderator, M. Iqbal Fauzan, SP, MSc. First of all, allow me to introduce our moderator. He's currently the lecturer of Agrotechnology Study Program, Department of Agriculture, Faculty of Animal and Agricultural Sciences, Universitas Diponegoro. His expertise is on soil science and land management. To M. Iqbal Fauzan, SP, MSc, time is yours.
Okay. Good afternoon, ladies and gentlemen. I hope all of us are in a good condition. Okay. Agriculture faces many challenges today, including climate change, depleted land quality, water shortage, poor water quality, and economic pressures. Modern farmers, however, do now have greater access to computational and geospatial tools that can also at least help mitigate some of these challenges. Geoinformatics is the one of the subjects that have increased. If you are talking about it, you will talk about spatial, or in the simple way we call positioning. Especially in agriculture, many applications could we do. For example, monitoring agriculture health using remote sensing, we could observe multi-temporally. For now, geoinformatics have been transformed into big data analysis, even artificial intelligence. To hear more about the application, this afternoon, I'm very pleased to welcome you to our invited lecture series organized by Agroeco Technology Program. And today, 11th of October, is the second series of the invited lecture program. First, let me introduce myself. My name is Muhammad Iqbal Fauzan. You can call me Iqbal, and I'm from Agroeco Technology Program, Universitas Diponegoro. Today, I will accompany our honorable speaker and lead the discussion. And now, we are already have Dr. Shahnawaz with us. Good afternoon, Dr. Shahnawaz.
Good afternoon, everybody.
Good afternoon. It's nice to see you. How do you do?
Thank you very much. I'm fine and looking forward to the participants.
Okay. Okay, everyone. Before we move to the main session, let me read Dr. Shahnawaz profile first. Okay, Dr. Shahnawaz is in the Department for Geoinformatics, ZGIS, University of Salzburg, and he has many projects. There are special reasons, special tech in and resource GIS, and also in academic and professional functions. First, in ZGIS as a coordinating international GI science education projects, UniGIS as a directing UniGIS network in South and Southeast Asia, and DOGG, Department of Geology and Geography, and he is teaching various courses. And his research interests curricula, competencies, and qualification in geoscience education, environment and development in mountain ecosystem, modeling and simulation of the dynamics of natural resources population interface in mountain ecosystems, dynamics of regional development in various sociocultural natural environments. Okay. Now allow me to welcome our speaker to deliver his presentation. Dr. Shahnawaz, are you ready?
Yes, I am ready. Thank you very much.
Okay, please welcome Dr. Shahnawaz. Time is yours.
Okay. Thank you very much for the nice words about your different introduction to the kind of activities you are doing, and also introducing the kind of activities I am doing. Now I start my lecture. Please confirm when you can see my presentation. So everyone can see my presentation now. Slide. Hello.
No, we don't see it.
You don't see it, or what's okay, first of all, can you hear me? Yes, you can hear me.
Yes, I can hear
Then
you.
I say share screen, so I share this screen. So you can see it now, right?
Yes, we can see it.
We can see.
Okay, fine, great. Okay, so Assalamualaikum warahmatullahi wabarakatuh. So good afternoon, everyone. Good morning at my place and good afternoon at your place. Thank you very much for giving me the opportunity of interacting with you. Thanks to the dean of the department and the moderator, as well as Ms. Rashida, who actually invited me for interacting with the participants and presenting this lecture to you. As was already discussed about this, that this is concentrating or focusing on the applications of geoinformatics for agriculture. But of course, whenever some technology or tools are being used for application in some particular domain, there are of course some opportunities as well as some challenges. And today we will see some examples how GI science, typically we call it geographical information science, can be applied in the field of agriculture. Okay, so I will start with an introduction to the spatial or geographical perspective, and what is spatial or geographical, and how do we know it is geographical or not geographical. Then I will talk a little bit about world or the globe, its natural part as well as cultural or social part, and then how it is converted into digital part. Geoinformatics, that we say what type of data are required and where are the sources of those data. And there are some examples of applications in the field of agriculture. And in between, whenever, if you don't hear me or there is any kind of problem in understanding my way of speaking, as well as if slides are not visible, please indicate it to the moderator, and moderator will tell me if I have to do something. So, okay, so we go with this part is, first of all, we look into what is the spatial perspective, because we talk about the geospatial aspects. So spatial is based on spatial cognition and spatial thinking, which means actually we perceive or look at the things, how they are located on the surface of the earth or over the space in atmosphere or anywhere. How are they located and how are they distributed? And by those observations, we try to find answers to some scientific questions or scientific explanations, which include what is happening and where. For example, immediately before this lecture, Ms. Rashida and me, we were talking about how is the weather in my place today. I said it is raining and it is cold, it is 14 degrees centigrade temperature. And she mentioned that my place is not raining, but it is cloudy and definitely the temperature is higher than this. Now that is what is happening, and there is at some place it is raining, and there it is Salzburg, like my place. But why it is happening there, not somewhere else, right? And why it is raining in Salzburg and not in Tamara. So that is where we try to look into that. Yes, there is a difference between the climatic conditions of these two places. They are located thousands of kilometers away from each other. Their geographical region is different. Your Samaran is related close to the equator, and the climatic conditions, daily weather conditions in the equator are different than where I am located, nearly 50 degree north. Then we say how and how much of it is happening. Yes, then we see why it is or how it is happening is, yes, it is a winter time already in Austria. And then how much it is happening is a measurement. How long it is happening, how much it is happening, we can measure this rainfall. Then we can also see for how many hours it was raining, and we can do the forecast.
Sorry, Dr. Shahnawaz, for interrupting.
Yes.
I think your voice is not clearly heard. It's shaky right now.
Okay, so now on the other side, how many people are using the video? Because that's what we had discussed, that they should stop to video, because that will put some load on my side of the. So please tell everyone to stop videos so that the bandwidth on my side is not consumed by video, because I don't need to use video.
Okay, maybe Agam, could you please turn off audio?
Yeah, video for off for everyone, because no one needs video. Even I don't need, because I am using presentation.
Okay.
So now, is it better now, the quality of voice?
It's better.
Okay, fine. Because you see, you don't know, on my side of the band, if the video is being streamed, then there are 100 people, and that definitely distributes the bandwidth. Okay, done?
Yeah.
Hello.
Hello. Yeah.
Okay, yeah, please keep on indicating if it is good or not good, and then I go further. Yeah. Okay. So when we have the observations for a longer period of time and on different parts of the surface of the Earth, then we can use these tests for modeling the future scenarios. That how these things have been behaving in the past for a considerable period of time, and having taken observations from different types of areas, then that can be made modeled to do the forecast of the future scenarios. And then this helps us planning immediately. When we can do forecast for the future, then we can also take measurements for planning, because we know how all these parameters will behave in future. If there will be a flood coming in the next days, then definitely we start planning for the evacuation or flood management activities. So that is where spatial is looked at. Whatever we can see how it is located on the surface of the Earth or above the surface of the Earth. For example, rainfall clouds are above the Earth's surface in the sky, and then we can take it location where there will be impact of rainfall. Okay, so that is what is the spatial perspective. Now you can see it, what is the advantage of having this approach of spatial perspective. because it helps us creating a range of natural, social, economic, and infrastructural parameters or indicators for better understanding of their relationships or how they affect each other, how they behave in the presence of other indicators. And then that's how we can see an integrated relationship among all those indicators or parameters for better and deeper understanding for a scientific explanation of various spatial phenomena. The same way we talk an example of rainfall, we can also talk an example of drought. We can also take an example of nature. So all these kind of things happen, and these are related to the nation of agriculture, how it will be impacting the situation of agriculture in a particular place, because agriculture requires some ground, some field, some soil. There is some need of temperature and humidity or soil moisture, as well as some nutrients. So all these things brought together can be used with the help of geodramatics approach to understand how they are related to each other and what we can do to bring better or more beneficial outcomes or products from that particular area. Okay, so this is my one part. I concluded here with a spatial perspective. And here, before I shift to the next topic, I would ask if you have a question or if you want to explain something more before we get into the next part. So please ask if you have any question, raise your hand and the coordinator will tell me which part I have. You can ask questions.
Okay, participants, now you can ask Dr. Shahnawaz in this first session, which is about the spatial perspective. Is there any participants who would like to ask? You can raise your hand or give your question in the chat box. I will read it.
Okay, so seems like there is no question as of now, so we can move ahead. Fine, so I assume that everyone has understood what is the spatial perspective and how do we correlate different parameters related under our research, and we can analyze them integrated in an integrated manner. Why it is needed is now I go to the next one. If we look at the world or Earth, right, it has two parts, major parts. There is a natural part and there is a social or cultural part. Natural part is that we see that all the energy from the sun is coming in a natural way. We are not asking the sun to send energy and how much and when. They're simply taking whatever it is coming. Same way, precipitation or rainfall is happening in its own place. Same way, there are number of trees and other vegetation growing on the earth's surface in itself. All the forests have grown naturally. We are not doing it. Evapotranspiration is happening. Clouds are being formed. Rainfall is coming down. There is water in the ocean. There is water flowing in the rivers, and all these things are happening in its own regulated manner. We are not doing anything for that. But there is a social or cultural part, which means the human activity, that the society is utilizing this natural space as well as the natural resources, because we are dependent on nature. Same way, if we are trying to do some agricultural crop cultivation, we need land somewhere. We cannot do it without any piece of land. But then what is happening is that the population is increasing, which means the number of users of this natural environment of natural earth are increasing. And immediately when population is increasing, their consumption of natural resources is also increasing, because each individual has its own need of these resources and they are consuming. Of course, living space is also increasing, which means we are constructing new built-up areas, be it buildings for residential purposes, be it universities, be it hospitals, be it roads, whatever, that we are converting that natural space into living space or humanly usable space. On the other side, the effect is that natural resources are decreasing because we are utilizing them more than their own capacity to rejuvenate or renewal. And since we are putting more pressure on the natural resources, then we are identifying that which resources can grow faster to meet our continuous needs. Which means even if the crop we are talking today that we want to enhance or increase the yield of particular crop, for example, rice, then this diversity, which means we are then focusing on cultivation of a particular crop or a particular variety of that crop, which can give us more yield, more product. So the diversity is increasing. Then, of course, natural space is being utilized by our human activity that is also decreasing, which means we are disrupting the natural ecological process of the earth. And then there is this conflict between how to manage, how we are managing the social or cultural part, or how the natural part of the earth is able to keep its balance. So this balance is not being analyzed, and this balance is taking several problems, which we talked about. One of them is climate change, and several effects of climate change are seen in different ways, including on agriculture and horticulture or animal husbandry. So what is needed then is, because Earth is too big for us to understand as like one unit, whenever we stand at some place, if we try to understand that what is this Earth, the Earth is too big for the human capability to understand it or analyze it, but the problem is done. But then in the modern age, we have these computers which are working with the digital information. So what we need to do is that we need to represent the real world or real features of the earth in digital form in our computer systems, and understand them, what these are, how they are related to each other, then try to manage them, that what can be changed to get better results or avoid any kind of harmful effects, and then communicate these to more effectively to the decision makers what to do. Because we cannot do this experimentation on ground. For example, if we see that is a particular crop which we think can be beneficial for the large amount of production, and we go and we start doing that experimentation on ground. But maybe it does not rain at the right time when crop will require, then that crop will be a failure, and we cannot do this experimentation because it will be too expensive and there will be shortage of food. But the same thing if we do it using geoinformatics or geospatial approach, and we can do this computer-based system.
Excuse me, Dr. Shahnawaz.
Yes.
I think your voice is not clearly again.
Again, okay, so let's take another bit, maybe sometime it happens. Now, how is it today? Hello, hello, hello.
Still shaky voice.
Shaky voice. Okay, so let's take one time. Then again, I am muting. Okay, so how does it work now? Is it better or still shaky? Hello, is it going?
Still
Again, good.
shaky, but how about to put off your headphone?
No, I am using headset. I cannot speak because my computer already had because mic is here. So if I am not using headset, then it is a larger problem because my mic is here. Okay, does it work better now?
Yeah, I think it's better.
Okay, fine. So I try to speak. So sometimes I think it is there that in every 10, 15 minutes it goes down. So let's try again. Fine. So everyone is hearing me now in a better quality of my voice. Hello.
Yes.
Okay, good. So this decision about what to do and how to do and where to do can be taken in a very effective and faster way if we can analyze all those things on our digital environment with the help of geospatial approach or the geoinformatics systems. Okay, so why to use this one? Geoinformatics or digital way of looking at the space we want to use this. We have the maps, which means the printed maps, we have it, but these have limited information, right? Because we cannot present each and every detail of the existing phenomena or features on the earth. And then this is also outdated, which means for preparing a map, first we need to do this land surveys, which one of the departments you have here. Then that is the survey data is brought into your lab, and then you plot it on a map and reproduce it, which means there may be very easily a gap of months when we have taken this ground observations and measurements, and when we have produced the visible results. And in between, we may not be able to put each and every detail, and that what has happened between the time of survey and producing a map, that change cannot be shown as well. With the approach of geoinformatics, we can see more details. For example, over this map, I can see now that, hello, yeah. So we see now that there are so many other details which were not shown on the map. Because this is a satellite image and it shows you the things as they exist on ground, and even more information has been added to this. For example, place names, there is a restaurant, there is a coffee house, there is university, all this information is added. So this is our first advantage, that we do not have much gap in capturing this image and visualizing it. Second thing is that we can also analyze the change. For example, look at this image now, which is from 10th of November 2001. And now, if you look at this, this is from 5th of January 2018. What has changed? You can clearly see a lot has changed already within these 18 years, and we can analyze that change very easily. So the second advantage is not only recording the surface in near real time, but also be able to analyze the change which has happened over a period of time. And this time you can keep on storing the previous data sets in your data bank, and then you can analyze it any time of series. Okay, now I try to conclude here. What is geoinformatics? So GIS workflow. We need to identify the features of interest, objects of interest, which are related to my field of observation or my field of analysis. Because I am not related or concerned with the whole world. I am an agriculture scientist. I am looking into the agricultural fields, maybe forest nearby, or some other things which can affect my agricultural activity. But I need to convert those features into a GIS data model, which is a digital data model. GIS data model means everything which I will plot or draw should have its location. Because if it does not have its geolocation, which means at which part of the earth it is located, and we cannot make out if it is Austria or if it is Indonesia. So each data set has its coordinate system and individual coordinates, and that helps us defining its GI location, geographic information or geographic location. Definitely, we need on the other side GIS analysis and presentation. What type of analysis should be done is dependent upon what questions we are trying to answer. And presentation, who are our target groups, whether these are students or planners or engineers or decision makers. So how those results should be presented to them, because all of them may not understand the technical part of GIS. Maybe they are just used to see a map, final map, and tell how much money. Example, decision makers, Ministry of Finance, may not be interested in knowing all other small that how you have created this data and how you have analyzed. Maybe they simply want to see how much area it is and how much financial investment it is required. And then it can help them making good decisions, and it can support their system much better and faster than we can do this in other channels. Okay, so here, is it clear what is the workflow of GIS or geoinformatics systems? If you have any question, please ask me here.
Okay, participants, if you have any question, please ask. Okay, there's one participant raised hand. Okay, Mr. Rehan Azariansyah, you can ask your question, please.
Give us some more. Thank you for
Voice is not clear. Can you please type in chat?
Okay. My question is, when we transform the real world into the GIS model, sometimes we do the misclassification, am I right? And then how to prevent, to mitigate the misclassification we do, like a digitation or classify using the supervised or unsupervised, something like that. That's my question.
Thank you very much for your question. This is what we will take at a later part, because that is already the analysis part. That how do we do processing and analysis? Currently, we are talking about how to create geospatial data. Yeah? So I take your question, I will answer it at a later stage. So currently is my question was that everyone understands that there is a real world which we observe all around. Yeah? It needs to be converted into a digital world with the help of GIS models, because there are data structures which I am going to talk about. And geographic means that they have a particular coordinate system and the coordinates, so that whenever we see that data of Indonesia is superimposed on data of Indonesia and it does not go to Malaysia or Thailand or to India or to Austria. So that is where I'm talking. And then I'm talking is that fine, it needs analysis. So your question I take and I will answer it in a later part. And I am talking about processing and analysis, right?
Sure. Thank you very much.
Okay, good. So if there no other question about this, then I'm going further that the world, now when we have mentioned, we see that this surface of the earth, if looked from above, it is not looking same everywhere and every time. We see there are some parts, natural parts, big stretches of forest. Then also we see there are some other green parts, maybe agricultural field, maybe playgrounds, maybe grasslands. Then there are roads in between. There are these built-up structures. We don't know if there is a house or a school or a hospital or something. Even after that, we don't know if this is a house, who is the owner. There is also a river, if you see on this left side, right? So there is a diversity of features and objects distributed on the surface of the earth. And this makes the difficult part, because we cannot put all this type of features into one data set. We need to separate them from each other. If we are interested in agricultural fields, then probably we have nothing to do with this forest or nothing to do with the houses. But if we are looking for a potential area to be brought under cultivation, then probably we need to find information which area is available. That may be some playground, that may be forest part, where new crop can be cultivated. So in a way that we need first to identify that which type of data we require and how to separate them from each other, so that we create different layers of data and they are not mixing with each other. Okay. So with this part, then why it is not going away? Okay. So if we look into this part, that this is a top view of an area where I am living. We see all types of features are made. So for converting these things, we have two major data models, right? One model is called vector data model, and one model is called a raster data model. So these are the structures that real world can be represented with the help of, why it is not sitting down there now. Okay, so there is a vector data model, which means the same way like we can make a sketch of any annotation I'm using. This one, if I have to make a sketch, like I am making, okay, this is the face of some human being. So I'm making these lines, and then I'm making, okay, there is eye, yeah, and there is this face, and there is nose, and this one. So that is called vector data model, where we can actually make the edges, right? That this is the outline of head, outline of this one. So with the help of polygon, polylines, and points, we can represent all the features of the earth depending upon how is their scale. For example, here, if we see in the middle, if this is the real world, so we have these, we have some buildings, we have a lake and a river. And on the left side, we can see that these trees, have been represented as points on the ground. River has been represented as a line. Lake has been represented as a polygon. And this settlement area has been represented as another polygon with a different color. And behind that, there is a definition, what is called attribute of each of these features. So point will be defined in a table as trees. Line will be defined in that attribute table as a river. This polygon, blue polygon, will be defined as lake, and this red polygon will be defined as a constructed area. But on the other side, it is difficult part, which means it takes time, first of all, to identify which object or features should be shown by which type of symbol, either point or line or polygon. And we need to do this manually, each and everything, like I am doing now. Yeah, I am making this face, right, for one polygon, and then I am making some point here, some point here, some point here, or a line here and a line here for river, right? But it takes time. I have to work, and the matter of accuracy is also there. On the other side, we have raster data set. Raster data set is representing all the features in terms of square. That raster is made up of picture cells, pixels, and then this can be immediately captured, and it is faster, of course. There is some noise coming up. Can you please check who is that? Hello.
Okay.
Okay. Now it's yeah. On the other side, this is this raster data set, which just now I had shown you this satellite image, and it can be captured just. I am sure every one of you have at least one mobile phone, and your mobile phone has this digital camera. So if you zoom into your digital camera, and if you know a photo which you have taken from that your digital camera, ultimately you will see that behind there are only pixels, picture cells. Yeah, and that is called raster data format. And you see everything here. What is a point here in this vector data set is a square here in the raster data set. What is a very smooth line here in your vector data set is, now you see these are not so square. These are kind of stairs, because it is no smooth curve, but rectangles. In the same way, your polygons of lake and settlements are also represented on this in rectangle edges, right? And that is the disadvantage, because you don't get a real shape, but that is distortion in the shape. And vector shape is very much accurate because you are drawing lines on the edges of the features which you want to represent. Again, as we said, there are advantages and disadvantages of both the formats of data. But again, we can decide which one can be used for which purpose. For example, if we have the purpose of representing this large stretch of forest, then we need not to make the individual trees, and then it can be raster data set, right? If we see this raster data set, which is showing us a very smooth stretch of forest, if we look back into it, then behind this is actually nothing else but pixels and pixels and pixels, you see. So it depends upon what is the size of these picture cells, pixels, what we call spatial resolutions, which means how much area is covered by each pixel on the ground. And that helps us knowing how smooth or how accurate are these features presented here. You can clearly see this is the same red block which I have here. Yeah. and then we can represent it. But that is not true about, and this can be taken from several satellites. We have so many satellites functional in the space, and they are providing us at different spatial resolutions. Of course, also some satellites run out of its lifetime. So we have older data, we have new data. There are several types of active and passive satellites taking observations of different phenomena, different objects on the surface of the Earth, as well as in the atmosphere. On the other side, if we have to represent this type of features, which means the constructed or cultural world, there are so many buildings, there are roads, the building owners are different, the use of the building is different, the names of different roads are different, and here we need to represent each and every feature, each and every object separately, and that is what we can do with the help of points. Like here we have trees and here we have spheres, and the polylines for roads or polygons for any kind of area features, we can represent everything of the world. And behind each type of feature, we define, there is a table called attribute table, and in that attribute table, we can write that this is a palm tree, or this is a conifer tree, or this is a mango tree. We can write in the table behind each feature. This is a grassland, though it is a polygon, but this is a grassland. Then there is another polygon, which is a forest patch. There is another polygon, which is a lake. There is yet another polygon, agricultural field. So they are polygons, they are area features, but behind each of these vector data features, there is an attribute table where we define its characteristics, what it is, how big it is, who is the owner, what is its area. If any other kind of information is required for integration, we can fill that table. And then geoinformatics provides us the possibility to do an integrated analysis. We can bring together several layers of these data sets. For example, here you can see we have customers, we have streets, we have land parcels, then we have elevation, we have land use, land cover, extracted from the real world, which is at the bottom. Each type we have presented it in a different layer, and by overlay analysis, we can do a combined analysis for any purpose which we are trying to explore research. And then what we require to reach at that level is this. First of all, we need to understand geography or geographic information or spatial perspective. We need to know how to use ICT, which means computer and particular software. And then there has to be an application area. We need to understand the dynamics of application domain. For example, agriculture we are talking now. If you are being trained in the science of agriculture, you understand it, that what is important. So soil is important, soil moisture is important, soil nutrition is important, the precipitation part is important, seed is important, fertilizer is important. That is what is your domain. But I am not from that domain. I am a planner. I want to plan some kind of buildings. For me, important is whether this is connected to the roads, whether it is the supply of water and electricity is there, how many people will be living there, how the ground is solid enough to for the construction of a 2-story building or 10-story building. So that is, we need to have expertise in the domain of application. So, but if you can start from from everywhere. For example, if you are from agricultural science, you can start with from geography. I am geographer. From geography, I needed to learn computer and software, and I am looking into different areas of application domain. I am a teacher, so today I am teaching it in agricultural area, but tomorrow I may be teaching it with the disaster management. Yeah. But on the other side, you are from application domain. You need to first of all see that if you understand what is geographic and how to use computer and this one, and apply it into your application domain. Or on the other way around, those who have not learned it, they are experts in their own domain. They understand how is the geographical perspective, spatial perspective related to the domain of your expertise. And then you look into which software and which type of computer you can use. So you can do actually from any side, depending upon which is your start point and where you want to go, and you can choose your path. And then the purpose of using geoinformatics is not making documents, not making maps. The result will be coming in the form of a map because it is a spatial result, but actually is your concepts of your domain, what you want to do, your understanding about the domain of your application. Then, based upon your concepts, right, you choose the data, which type of data is required, and whether it is for a larger area of surface or smaller area, or for a longer period of time, for a small period. And then you do this kind of analysis, whatever way you do processing and analysis, you bring out new information. And that information is then presented to whoever is the user in an understandable manner. That is where is the role of geoinformatics, which means you integrate your concepts and data, you analyze, bring out new information, and communicate to the target groups, whoever are the users of that particular new information, right? And that is where this whole story of informatics. Fine. So I give a little bit here as well and invite your questions. Hello.
Okay, participant, if you have any question, you can raise your hand or give your question in the chat box.
Yeah, MC Irfan, Yusuf, Fakhruddin, Fakhrozi. I'm sorry, I'm not able to read it fully, but yes, there is one hand. So please go ahead. Can you please unmute him if he is muted?
Please, Irfan.
Hello, check. Is my mic clear?
Yes.
Okay. So, dear Dr. Shahnawaz, I have maybe a very basic question for me myself an agronomy background. So, for the way I see it, I have maybe a question in terms of obtaining the most updated satellite image. Which kind of option is mainly the affordable one, and the drawbacks that might occur on choosing such option, and also what is the most broadly used option to obtain the most updated satellite image?
Okay, so this question I answer now. As I mentioned, I'm going back into some slides and I'm showing you that this one, right? As I mentioned that there are countless satellites capturing data every day. So depending upon the purpose is because we talk about time and spatial resolution. For example, this Landsat series of satellites can provide you data from 1972, which is nearly now 50 years, right? So, but then depending upon what is the aspect of your analysis, if you are trying to analyze something, for example, let's say some fields in Samara, right? So agricultural fields in Samara, right? So this resolution, so as I mentioned earlier, that in the raster data set and satellite images are one raster data set. What is the size of its pixel? Whether it is covering 30 square meters or 90 square meters or 100 square meters, then you cannot find, I don't believe that there will be one agricultural field of 100 square meters. So, yeah, or 100 meters long and 50 meters wide. So it always depends upon that what is the purpose of analysis and then which data will be suitable. Because two things mattering is that spatial resolution, that each pixel of that image, how much area it is capturing, because in one cell can be only one value, which means only one feature. So if your feature, for example, if we talk Landsat 1, its resolution was 180 kilometers. 180 kilometers definitely is too large for any kind of agricultural analysis. So that will not be suitable. Now, whatever the free data, okay, there are commercial software satellites which can give you centimeter resolution data. But if we are dependent upon free data, so Sentinel of European missions or European Union satellites, Sentinel 1, 2, 3, is still not there. They have a data resolution of 10 meters, and this is a free data. But there are also some other companies which are providing data for research purposes free of cost, and that may be just 1 meter or 50 centimeter resolution. So it always depends upon the two things, that what is your area of scale of analysis or topic of analysis, and how much spatial resolution is relevant for getting the proper analysis. Second is that whether it is free data, you are doing it for demonstration and learning purposes, or you are going to do it commercial activity, which needs to have very accurate, not like our teachers' learning process, but actually on ground reality results. Then you have to see the scale of your application. So it always depends upon that in which area you want to apply. All types of satellite images are available. How much money you want to spend or you can spend, and what is the time? Is it okay for you to have a data set of today? Yeah, you just put a drone. Everyone has a drone today. You need not even satellites. If you are just doing a monitoring of 5, 6, 7 experimental fields, yeah, then someone has a drone. You fly the drone just now, and in half an hour you have the data of now. And that is very high resolution data. So to some, it is millimeter data resolution, right? So that is what it is. So does it answer your question?
Yeah, I think so far the question could provide my curiosity in the basic level. But thank you, Dr. Shahnawaz. And also there might be another question. This might be very basic in terms of GPS or GIS, some of the geographical positioning system. I have a question. I've heard about Galileo is like positioning system developed by ESA, the European Space Agency. So what is the difference between the Galileo and types of you are describing in this very presentation? Thank you very much.
Thank you. The question is totally two different systems. Galileo is same like it is a global navigation satellite system. Like GPS is from USA, GLONASS was from Russia, Galileo is from Europe. India is starting its own. China has its own. So, do you use Google Maps on your mobile?
Yeah, I do. I use Google Maps on my mobile.
Yes. Today, every mobile has a location equipment. Don't call it GPS, because global positioning system GPS was a network of satellites launched by NASA in USA. So which means there are a number of satellites which are actually releasing some kind of signals, and then this signal is going back from your equipment and it provides you your location. It does not provide you any other spatial data. It simply provides you the location of that particular equipment, whether you have handheld GPS equipment, or you have your mobile phone, or there is any total station installed. So this global navigation satellite systems, they have different names, same way like our geospatial data capturing satellites are there. So it is a totally different segment of the satellites. So they don't provide you any visual data. It just provides you the location of that particular equipment you are using, right? So that Galileo is doing it for their own system, because definitely they want more accuracy. GPS is a global system and that is world over, but definitely it is controlled by the American military services. They have the ability and option to control the accuracy you get. It can be 10 meters, it can be 1 meter, it can be 2 meters. So getting finer resolution, finer location accuracy, each times European Commission or European Union, Galileo they are launching. Russia already had it, this GLONASS. India is launching it, China has it, and I think Southeast Asia, Thailand people were also doing some kind of thing. So this is for improving the accuracy of your location coordinates, so that many precise things, which means it is also applicable in your precision agriculture. I will come back to that, this one, but they are just providing you the location of the equipment you are using. Whereas these satellites, which are providing you images of the captured from ground surface, are a totally separate segment. And here we are not talking about GNSS systems, global navigation satellite systems, but we are talking about here the global image providing system, right? Clear?
Okay. It's very clear, Dr. Shahnawaz. Thank you for the knowledge.
Okay, good. So I move ahead now.
Yes, you can.
Okay. So we were here at the beginning of first example of the application. This example is to find the potential area for crop cultivation in Bhutan. I believe everyone has heard Bhutan, a very small country, of India in the Himalayas, and it's a very mountainous country, and definitely they need to explore more areas suitable for agricultural activities. So what we did is this. I will provide this presentation to Dr. Or to Ms. Rasida, and she will share it with you. You can also explore this research paper is available open paper on my ResearchGate profile. So first of all, we needed to identify is what is the major crop, what is the staple food of the people. Then I looked into is that in 2012, maize or corn we know, paddy or rice you know, and then wheat. These are the three major crops. Nearly so 46% of the area in 2012 was under maize, which means of course that is their staple food. Then paddy or rice is nearly 38%, and the rest are very small proportion. So two major crops are turning out to be clearly see now the seasoning. Maize and the corn and rice, they are growing the same season. It's the summer season, is the mountainous area, but then their requirements are different. Maize or corn does not require that much of water or soil moisture as it not. It is a flood agriculture, right? So we started looking into that which areas are suitable for extension of these three crops. And then we first of all identified what are the parameters required for this. So these were the parameters. First of all, we looked into which are the cropping season. So for maize, May to August, May to September. So there is an overlap. There is a competition of space. Whereas wheat is winter season, November to April. So it does not overlap with the two other crops. Then we looked into the physical parameters. Since this is a mountainous area, so we can test upon which are the sunny side and which are not the sunny side, which are called aspect. And the slope degree, it matters. How slopy is that area, then we can make the fields or not, or even by law in Bhutan, no cultivation can be done on the areas where there is a slope more than 40 degrees, irrespective of the fact that it is a terraced agriculture. They create fields by creating terraces, like steps, but still no new area can be allowed because there is a possibility of landslide, loss of the resources. Okay, so these were the physiographic parameters we needed to explore. Then there is a temperature parameters, right? That how much minimum temperature is required and how much maximum temperature for the healthy growth of this. And then also how much rainfall is required. And you can see clearly that in maize we have not defined it. Reason being is it is actually a dry crop. It does not require much rainfall. That's why it is there, right? Okay, just 1 minute, please. Okay, and then for other things we looked into that this much rainfall is required for paddy and for wheat. And this what we have done is taken from the different kind of applications, but already the people have used previously from agronomy or whatever, and we took it, right? Now this is a criteria that we will start identifying in each data set that where are we meeting these criteria, and that is what is the area suitable, and where we are not meeting this criteria that is not suitable. And then we will actually overlap each of these criteria layers. Yeah. And then we see where all the information is meeting, that will be suitable area, and others will not be suitable. So this is how we can classify our data sets, that we excluded everything which we did not need. For example, we only took asset from 90 to 270, but before 90, which means 0 to 90, 200 to 360, because Earth is round, you know, that there are 360 degrees. So the northern part are no semi parts in the northern hemisphere in the mountain regions, which is other way around in the southern hemisphere of the Earth. The southern slopes, southern facing slopes do not get direct sun. In the same way, we defined the suitable degrees and defined the mean monthly temperatures for these months, and then precipitation for these months, and then we got this result. You can see we had taken the data for whole Bhutan, right? You can see the boundary of Bhutan. We overlaid all these parameters, which is aspect, slope, temperatures, and rainfall for the months which are the cropping months of this crop, right? And then we found these red ones, these are suitable, and all other areas are not suitable. So it helped us find out where we can go and try to grow, and not then go somewhere and try to put our resources and time, which is actually not suitable. And then we lose our time, we lose our resources, money, funds, ultimately no result. So this is how the decision support system, ultimately we make decisions. Yeah? We cannot go just very far away from the settlement, start cultivation there, because people have to do it. At least know which are the areas suitable, we can try to cultivate there. And now this is keep this area in mind. When we see this area, that you see paddy, all the area which are suitable for maize cultivation are not all of them suitable for paddy cultivation. Reason being is because this area for maize cultivation or cultivation is higher because it does not require much rainfall or much water. So water was not the limiting factor, whereas this was the limiting factor here. Because paddy requires lesser slope so that water can be retained in the fields, and there has to be enough supply of water. You can see this area is much lesser than this for maize cultivation. And wheat cultivation is a winter crop. This is a mountain region. Temperature turns out to be another limiting factor. So then we see that it is not suitable for the southern parts or the northern parts. Just only in the middle parts it is suitable. Otherwise, it cannot be grown. So you can clearly see a difference in the suitable areas for cultivation of wheat, cultivation of paddy, cultivation of maize. So that is where we could get very precise results when we integrated these parameters and defined them, reclassified them based upon the previous experiences of the people, what is required in terms of its physical parameters and the rainfall and temperature. And we could get this entire idea. So this is one example. We could actually calculate that how much area can be increased. We can clearly see that there is a lot of potential to increase the area of maize more than double, 101%. There is very less possibility to increase the area under paddy or rice. And in wheat, yes, sure, there is a lot of potential. But the limitation factor is in the area because the mountain area. Also, we did it for one commercial crop, which is a tea plantation. And you see, tea plantation is only in the eastern part, that too more in the southern eastern part, and the western part is not at all there because of the rainfall. Eastern parts receive more rainfall than the western parts. I believe that Indonesia also has a lot of tea gardens or coffee gardens, and you know this has very specific need of precipitation or soil moisture or humidity. So this is what was the first example and how we can use GIS or geoinformatics approach for finding out areas suitable for a particular crop. And it can be any crop, doesn't matter. Only you need is that you identify these parameters very carefully, and this is where we say your domain knowledge of your application area, be it agriculture, be it engineering, be it planning, whatever. And here you can identify those criteria, classify your data set according to that criteria, overlay them, and then you get where all the parameters are suitable. Those areas will be presented to you. Where any one factor will not be suitable, that area will be excluded. And then that is what the result you get. Okay. In this part, any question?
Okay.
Hello.
Participant, if you have any question, please raise your hand. No question? Okay, let me see.
Two participants raised hands.
Okay, there are two participants raised hand.
So please ask them one by one.
Okay, first maybe Julian Christopher Limantara. You may ask your question now.
Okay, thank you, Mr. Iqbal, and hello, Dr. Shahnawaz. Can you hear me?
Yes, I can hear you clearly. Please go ahead.
Okay, my name is Julian. I'm alumni from Agroecotechnology. Indonesia has a big field, but it divided in a small area which managed by different farmer and people. So how the strategy to implement GIS into a small scale? In the past, you say that GIS it's effective in a big area, but in Indonesia, farmer has a small area. So how it can be implemented in Indonesia? Thank you.
Thank you very much. Very good question, right? But I was talking in the beginning, right? When I was talking about is that we are looking into which areas are suitable. That is one level, right? And then what you do as a second level is that you overlay those parcels, right? You say the field parcels. Yeah? Field parcels you overlay, and then you can see that which of the farmers have that area or their fields fall in the suitable area, and it is a decision-making process. If there is any government policy to go and or any agricultural promotion policy to go to those farmers, because when you have identified this way, you see the parcels we have talked about here, that each of the area belongs to someone, and behind that there is the name of the owner, right? So if you overlay that parcel information on the areas which you have found suitable, and you can immediately identify who are the farmers, and you can give them a suggestion that for your field, this crop is better. And of course, the owner is the owner. They can decide to have that crop or not. So I'm saying is it is a decision support system, not decision making system. Decision makers are the owners, or if there is any kind of policy enforcement that in this particular area you can crop this, you can cultivate only this crop. Yeah, it's there. So at the individual level, if the size of the field of those people, the farmers, is not big enough to take support from GIS, if they have a small field and they have to feed their family of 4, 5, 6 members, they will not use GIS. GIS is needed for a large scale analysis. For individual farmer, that would be okay. One time we will talk about precision farming. But again, immediately you have to think about it. The same question I was answering with the last participant, that it depends upon what is the scale of your observation and analysis, and how much money you spend on that for taking satellite image, for generating GIS data. Because if your field is only kind of 10 meter by 10 meter, and you can just walk there and you know your field, what to do, what not to do there. You know what your neighbors are doing and your forefathers, parents have been doing there. So it is the question related to a large scale planning. Field to field planning can be okay for at the most that you go and say, okay, what kind of nutrients? So you do all kind of this soil analysis, the physical and chemical parameters of that soil. This soil is a alluvium soil or it is a sandy soil, and what type of crop can be cultivated there. And you look into what is the soil moisture type. Of course, the texture or physical texture of soil will tell whether it can retain water or not. And then the chemical properties will tell what type of nutrients are available and which type of nutrients or the fertilizer will be needed for particular crop, but they are showing. But then it's a very small field and it can be done just without doing any kind of such big GIS analysis. Because matter is that how much funds you spend on that, how much other resources you spend, what is the outcome. And on the other side, if there is a continuous area, nature does not change so fast from each next to next, which means if there are 10 people next to each other, their soil properties in terms of physical and chemical will not change from the other owner who is right next to me and then the other owner next to me, because it will be actually a large stretch of area where these properties will be more or less the same. So the planning will be done at that spatial or regional level rather than just on each field. Right? Understood?
Understood.
Okay. So but there is the next question.
Okay,
Okay.
thank you.
Okay, thank you, Julian, for your question. And then we move to the second question from Mbak Anggraini Nur Hidayah. You may ask your question now. Halo Anggra.
Okay, thank you, Sir Iqbal.
We don't hear your voice.
On my mic due to my biasanya kuat. So, can you hear my voice, sir?
Okay. Please.
But we didn't hear
Sorry,
your question.
Can you hear my voice, sir?
No, I could not hear anything.
Okay,
Can you
Anggra, maybe
write
you
it?
can ask your question in the chat box. I think your voice is not clear. Halo Anggra. Please ask your question in the chat box by typing.
Yeah, Mas.
No, it is taking time. We cannot hear. Either she writes it or we keep it to the end, because then it is disrupted. I have to kill other things to catch it.
Okay, sir. You can move to the next slide.
Thank you very much. So I move further. Yeah. Okay. So this was an example of finding suitability analysis, what we say, and this can be applied to any domain, depending upon which parameters, what are you analyzing, and which parameters are important for that. Okay. Now, related to one agriculture, which is a worldwide problem, we already know that climate change is making bigger problems. Somewhere there are floods, and somewhere there are droughts. So the second study, what I'm going to present, is related to the pre-analysis of a possible drought, which means there are some indicators which, if analyzed timely and in a good way, then we can see if this particular area is going to have a drought condition or not, and we can provide irrigation, or we can look into over a period of time if a particular area is having drought conditions time and again, so to develop irrigation possibility, irrigation facilities in that area. This is a case study from India. One of my master students has done it, and so you can clearly see comparison of indices for agricultural drought monitoring in Karnataka state of India, which means there are number of indices given, there are number of formula given, one, and always believe that there is no single formula applicable for whole world, because every conditions are different at different places, different areas, different countries, and in one area you may have some data, and in other area you may not have that data. So different scientists, of course, we are scientists, we are academicians, and we have a responsibility of developing and testing new methodologies and technologies. Then here we see which one are actually important. We have compared 5 different formula or indices, and then looked into which one actually relates to the reality. So what we had done was this one, right? That we had first of all identified the past years of drought. So, like for example, when was the last drought? 2 times before. As I said, that for future projection, for forecast, or for modeling for future, we need to see how is the trend of a particular aspect in the past. And then we have looked into it for 2003, 2007, and used this data for projecting the future. And how does it match with the past trends? And then it would be reliable for the future. So there are a number of indices you can see. There is this vegetation condition index, DCI. Then there is a TCI, temperature condition index. Then VHI, vegetation health index. Then soil moisture condition index, soil moisture agricultural index. Then modified temperature condition index, which is a part of other indices. So there are a number of indices. You need not to remember now. just want to demonstrate that, see, so many techniques, so many methods are available, but this depends upon it has data required as different, and then also that what kind of climatic conditions exist in particular area and what type of seasoning exists, right? So this kind of thing that we get here is the formula for each and every the 5 which we have tested, right? VCI, TCI, WSI, SMCI, and SMADI. These we tested and we tried to look into which one is the best of them for our study. Then we looked into which data are required, these data sets. So these data sets we looked into that we required normalized differential vegetation in TVI, which has taken from this satellite, Terra Novis. Yeah, it is freely available data. We have used all the free data available. What is its resolution is 250 pixels, and it is appraised for 16 days. Right? Then you have land surface temperature that is also from the same satellite and sensor, which is 4,000 meters, and then it is provided at 8 days. If you combine the 8 days, then you get average for the 16 days, because we also needed to have the same temporal resolution and same spatial resolution. Then the soil moisture was available at near 27 kilometers, and it was available for every day, but we again aggregated it for 16 days. And on the other side, I don't know why this is not, sorry, why it is not remaining here. So what is this? Okay, anyway, so I don't know where to put it. I am moving it a little bit outside here. For the moment, let's put it here. Okay, then we have this data of rainfall, tropic rainfall resolution, which is also providing about 27 kilometer resolution, and it is also available for daily data, and we have aggregated it for 60 days of our analysis period. So these were the data sets we required, and in indices I already mentioned which indices we were looking into, and then we processed it, and we categorized the 5 drought severity categories based upon the value of indices for these 5 indices, right? So for TCI, TCI, and VHI, so 0 to 10 value was extreme drought, and then the red values are extreme drought, which means it is really dangerous for crop killing. It is a severe, moderate, and when there is a dark green or light green, they are no drought, or it's a pre-drought stress, and it is going from green to red, where it is a severe drought or extreme drought and no crops are surviving. And then for SMCI, the value ranges from 0 to 100, whereas for SMADI, it is from 0 to 40. Same way for VCI, DCI, and VHI, it is from 0 to 40. So having classified this data, and these are the maps you can see now, right? Let me move this from somewhere. Okay, there is a, so you can see now from 18th February 2002, we were doing it every 16 days. So 2002, because at this was the time, in 2002, there was a severe drought in this area. So we started looking into from February that if the indices and the kind of data sets we were using, did it already let us do pre-analysis that where is going to be a drought condition, so that the farmers could be told that, hey, please use water because there is going to be drought, right? So we did it for 18. You have already seen that we were doing it for 16 days gap. So it was 18 February, 16 March, 22nd March, and these are conditions of drought. This one, you can see each condition, each indices have different result. So depending upon the kind of formula they were using, the way they were processing these data sets, and what kind of data sets they were using, right? And you see all the results are different. Yeah. Okay, so this is one map for 2002, there are all the maps are available here. You will get this, you can open. I don't want to open because there are hundreds of maps. And then next map you can see is this one. That for the 2007 condition, again, you see the results are very different from each other. Whereas some results of BCI are showing that there are only green areas, whereas this SMCI is showing right from February that there is an extreme condition of drought. So it depending upon which data, which means which parameter or which indicator was taken and how it was processed. Okay, so this is the result. We'll conclude it later that how we looked into which one is the better. Again, all these data sets are available. You can go and you can see all other maps. And then you see now conclusion here of this part, right? This is the conclusion. Indices that are derived from multiple indicators will be VHI and SMADI reflect actual drought conditions better than those derived from single indicator VCI, DCI, or SMCI. So one time I go back and we say VHI and SMADI. So this is VHI, right? And this is SMADI, right? You can clearly see that they are showing that the drought condition from February to March to it is increasing and the trend is more or less same. So because they have taken more parameters into consideration than only one, like this was only NDVI. NDVI is already an outcome of growth if, for vegetation health, right? So this is where we could actually look into what is going to happen in the next month so that timely irrigation management could be done. Even though both VHI and SMADI look better during 2 drought years, SMADI was found more suitable representing the conditions during the non-drought years. So we were looking into not only the years when there was drought, also we looked into when there was no drought, so how was their behavior going on? So ultimately we were finding that SMADI turns out to be the real good indicator for this particular area to do the pre-assessment of drought which is coming in the next month so that we can already see provide more early warning systems. So this is what it is, right? This was a conclusion of this one. So again, here is my second example finished. Then I will talk a few other things, but if you have any question here, please tell. There is one hand in chat or one chat is there.
Okay, Dr. Shahnawaz, there is one question from Angra from previous session in the chat box, and the question is about when we transform data, especially from vector to raster. For example, when we have to make slope maps.
I am reading it. Thank you. Please don't.
Okay.
I am reading it.
Okay.
Because then I am hearing you and I am reading myself. It's a cross. Okay. I am reading it. Yeah. So she's asking about is the question. Probably everyone can read it themselves because it has been posted to everyone. It says from when we transform data, especially from to raster. For example, when we have to make slope maps, but we used to put the data from a vector, not from them, the area that places outside the pixel, which has a tolerance limit in this case. Okay, first of all, my question to Angra is thank you very much, technical question, which is a crucial question for physical analysis. So first of all, that is never a good idea to convert data from vector to raster. Clear cut, because we know vector is either point or a line or a polygon, whereas raster is a square, depending upon the resolution. So why there should be a need to convert the data from vector to raster when there are free DEMs available for all over the world? So why is the need? Should not be converted, sure, but why is the need? Why you are not using the DEM which is available? Currently, free resolution, free DEM is available, and that resolution is at 12.5 meters, and it's quite high So why there would be a need to change or convert data from vector to raster? Angana? Hello.
Angra is has a bad signal for the internet.
Okay. So yeah. So first of all, there's no idea to convert vector to raster, especially in terms of such features. There has to be a continuation of data. Raster data is a continuous data. Probably you forgot one thing. I am going back and telling that thing again. That what is the difference? Why probably there is little bit gap. Yeah, we see continuous feature data, raster data, right? And vector data is a discrete feature vector data. So now if we take the example here, that if you are taking this line, let's say 2 and this line, we know the values of these two lines, but we don't know what is in between. And whenever you are converting or whenever you are doing interpolation, it is not conversion. Conversion would be different. So if you are converting either from points or from polygon, points which means these are spot heights and these are contours. If you are doing it, that is called interpolation. Interpolation means you know the value of this point, this point, this point, but in between the values are considered that there is a smooth change between these to this, which is not true in terms of surface. So that is never a good idea. It is good enough to learn the process. And if you don't have any other alternative, to have some data, but that is not good approach. You should not use this way. It should be used when free data is available at 12.5 meters, right? Allows data is allows parser data is available. Free data you can download it from NASA website, right? And it is 12.5 meters, which is very high resolution, 12.5 meters in terms of digital elevation model. Thinking about not mountain areas, but largely relatively flatter areas. But it is very good data. So there is no need actually, and it is available free. So please leave that practice of using this one. Clear? Any other question?
Any other question from the participant? Let me see.
Okay.
Okay, no
if
question.
there is no question, then I go a little bit. Just please.
Okay, please.
Hello. Should I go ahead?
Yes.
Okay.
Yes, sir.
So we already discussed two conditions, right? Which are very important to find area suitable for new crops. I have just demonstrated that there is an approach which helps us identifying new areas suitable for cultivation of particular crops. We just need to identify requirements for the cultivation of that particular crop, and we can manage our data sets and find out where that crop can be cultivated in the whole of Indonesia. Indonesia is thousands of miles from one island till Papua New Guinea, right? And this is okay. Climatic conditions are not so different, but definitely it may be suitable for some other things as well. Now, of course, one major challenge is always land use, land cover, right? That how the land and land use is happening and where it is happening, where the agricultural activities are extending, where living space is extending, where forest is being cut. So that's monitoring. Of course, from the data which was captured by the satellites or the images by the satellites years ago, and then we can see what the change has happened. For example, this is change in Kathmandu Valley in Nepal between 1978 and 1995. So nearly 18 years, 17 years. So this kind of analysis can be done from the repository of previous images and the new images, and we can compare and we can find out which are the hotspots of land-use land cover change and where to make a policy. Or if there is any illegal expansion of agricultural Because if you want to do animal husbandry, livestock cultivation, or any kind of dairy in this one industry, then you need to have a large area. Because the number of animals will be very high, and their requirements of maybe grassland or their maintenance will be very large. So finding area away from the settlement and still not in difficult areas, it can be found. These are the suitable areas, and then of course you are the decision maker where you want to do, where you don't want to do. Here I will also explain an example of precision agriculture. Precision agriculture, the name itself says precision, which means it is very precisely and planned for the smaller areas. So, for example, let's see that these are widespread agricultural fields where the climatic and physical conditions may vary. Precision agriculture is based upon all these computer-aided implementation of cultivation, right? So if we have to see that our one tractor or one vehicle is going around on that area, or even if it is a drone flying that area, or spreading particular type of nutrition or artificial chemical fertilizer, but then it should not be given where that particular nutrition is available naturally in the soil, or it should be given in a more quantity where it is not at all. So first of all, you need to develop that database of that particular land. You need to identify which are the areas where this nutrition is sufficient, which are the areas where nutrition is in deficit. And you put this all into this big data cloud, somewhere in spatial data infrastructure, and you program it. You program it with that computer that whenever the value of this particular nutrition is falling below, let's say 10 points, then the drone is trained that you have to spend here 2 kilograms of this particular nutrition. So this drone or this particular vehicle is moving on that area. It is this ready-made data available in your data infrastructure, and it knows that where it is going now, there is a need of low or high spike of nutrients. So that is where we go for the precision agriculture. And immediately when we say precision, the data precision is the first requirement, that you identify those zones or those fields, and whatever is the requirement in terms of nutrition or water for that particular area. It cannot be each field. As we said already, that the nutrition structure, the physical and chemical structure of that particular soil, it does not change just like meters. These are large, huge areas which have more or less similar properties. And the land management or soil management or field management is done by that thing. So this is where we need actually at the back end spatial data infrastructure, where we need to feed in the ground reality, and then make program that every time when you are passing by, because then now the question of GPS or this global navigation system is also coming, because then your vehicle or drone is passing by that location. So its location will be captured by GNSS, that where it is. And immediately its location will be integrated with the data set integration. And then the supply will come about its natural parameters and how is the relation of nutrition or soil moisture here. And that quantity will be applied as needed. So that's why it is a cost-effective precision agriculture. Right? Clear this part? Any question about this?
Okay, any questions, participant?
It doesn't seem to be, so I go next and we conclude and we have together some questions. Okay, now we're concluding with the last thing. First of all, what is important for all this process is concepts. That you understand its theory, its concepts, its fundamentals. What is a geographical information system, GIS, geomatics, whatever, right? What are the dynamics of your domain of application. These two things are very much important. First, what is GIS? What is the dynamics of your domain? And you can find out what it can do for you. And in between, which data and which tools you require. Major two things are, two ends are concepts of both the things and the application. And in between, which method you will choose, which data and tools you will choose, will depend upon how well you understand the concepts of geomapping and the dynamics of your application domain. That will help you doing all these kinds of solutions, decision making, decision support systems, and analyze for yourself the inform the results rather than experimentation on ground, and getting that you have spent your resources, human resources, material resources, financial resources, but at the end you find, oh, the result is not really good, but you have already spent the resources. And this experimentation can be done with the help of mathematics in your digital environment. And then you can see, yes, there is the possibility that we will have better results. So better we try there, rather than looking into that some areas are not really good for experimentation. So you don't waste your resources. And that is where is the, we say, effective decision support system. And that much is there. Thank you very much for your lecture. And here is my last slide. Here is my email. You can ask questions now, or if you put later any question, you can send an email. We'll try to respond and that we can solve some further steps. Thank you very much to all of you, participants and organizers. And I am happy to take the questions, any which are overall or further questions.
Okay, thank you very much, Dr. Shahnawaz, for your lecture presentations. We got many information about GIS and also for agriculture. And maybe for one question, last question, is there any question from participant?
No, give them time. Don't give the data. Just now I am happy. We have to make it. I believe some people would have to leave.
Okay.
I'm available for the question. Some have already done. Some are leaving now. Again, those who want to discuss more things, I am available. And I think we can take some time if they ask.
Okay.
And if they don't ask, of course.
Okay. If participant would like to ask, just please contact Dr. Shahnawaz. Okay, thank you very much, Dr. Shahnawaz. We are very happy to attend your lecture here, and I hope we can meet in person in Semarang. And thank you very much for joining our visiting lecture. And Assalamualaikum warahmatullahi wabarakatuh. I will give it back to the MC.
Thank you very much, and walaikum salam.
Okay, thanks to our moderator, and Iqbal Fauzan, MSE, for leading this session. Ladies and gentlemen, we would like to convey our sincere gratitude for our today's speaker, Dr. Shahnawaz. As a token of appreciation, we are very honorable to grant Dr. Shahnawaz our certificate of appreciation.
Thank you very much.
Okay, now we move on to the next session. Okay, ladies and gentlemen, now we come to our closing session. And last but not least, I would glad to leave you with a quote by Tenzin Gyatso, the 14th and the current Dalai Lama of Tibet, who once said, "Whenever there is a challenge, there is also an opportunity to face it, to demonstrate and develop our will and determination." Throughout the essence and wisdoms that we have learned in today's very meeting, may this moment lead towards the breadth of will and determination in all of us to take the opportunities that lies within every challenge ahead of us. And we are very thrilled once again for your presence in this very meeting. Till we meet again in the next very meeting, Have a blissful and healthy day. See you.
Thank you very much. Can you please thank you for everyone is taking time. I hope it went well, and one part was that the white noise quality worked much better than we were afraid about. And then hopefully we will be having other opportunity of interaction in person or so. I have been to Samarang one time along that, I think in 2012 or so, but I did not have the opportunity to go there. And so others can leave, and still those who are organizers here can stay. I would have some.
Oke. Oke. Ya. Ya, untuk peserta boleh bisa meninggalkan